Today we're going to talk about Newton's second law of motion. And in words, Newton's second law states that acceleration is directly proportional to the net force and inversely proportional to the mass of an object. Now, that sounds to me like an equation, and it is. The equation, some people say, and one way to remember is something you might say force equals ma, right? I've said that in the past. But I actually like to talk about this equation, just rearranged a little bit. This is the same equation right here. This is the way I want to discuss Newton's second law. The acceleration equals the sum of the forces. This little weird little like sideways W thing, or this weird E, is an epsilon. And it means the sum of. So like, let's say I have object, and there's a 10 Newton force that way and a 5 Newton force that way. The sum of the forces on this object is 10, because 10 is to the right, 10 Newtons. 5 is to the left, so I'm going to say negative 5. So 10 Newtons plus negative 5, which I'll just say that's 10 minus 5. So the sum of the forces on this object is 5 Newtons, right? So that's what the sum of the forces means. It means add up all the forces, and what is the net force? Like, what is the overall force once you add them all up? So that's what the sum of the forces means. And then I've got all of the variables labeled here, right? F is force, and the unit for force is newtons. M is mass, and that's in kilograms. A is acceleration, and that's in meters per second squared. And of course, the sum is add them all up, or we call it the sum of, or the net force. So what does this mean? Well, here's an example here. I've got this object. We're going to say this box and this box have like the same mass. We're going to say they're both the same mass. And I've got this giant dude pushing on this one, and this little bitty dude pushing on this one, right? So what would you expect to happen? Well, I'm guessing that you can pretty much see that, like, well, this big guy is going to be pushing a lot harder. And you might say that that means that this object will move more. Well, we have to be more specific than say move more, right? We have to say it's going to accelerate more. So this object, we'll call this object 1, and we'll call this object 2. Object 1 is going to accelerate more because there's a bigger force pushing on it, right? Where this little one, it's going to very slowly speed up. Object 2 is going to slowly speed up. Object 1 is going to go whizzing off because this giant force is pushing on it. And look at this. That's because force is directly proportional to acceleration. So the bigger the force, the bigger the acceleration. Okay? That's pretty simple to see. Now let's look at my other example here. We'll call this, I'm gonna erase object 1 and object 2. We'll call now this object 1 and object 2. Now we got the same size person pushing the objects, and we're going to assume that object 1 has a lot more mass than object 2, right? And now what do you expect to happen? Well, I expect that object 1 is going to very slowly speed up, and object 2 is just going to go zipping across. So you're going to end up with more acceleration on object 2, more acceleration on the smaller mass. So the less mass, the more acceleration, right? And that works well with our equation, right? Because you see the mass here. Let's just say that our force is 1. Let's say our force is, for the sake of this argument, let's say our force is 1, and let's say our mass is 1. Okay. Well, then acceleration equals 1 in that case, right? But let's double the mass. Let's say the force is 1 again. And now let's say the mass is 2. Well, now guess what? Acceleration equals 1/2 now, right? And so as you can see, the bigger your mass, the less acceleration you're going to have. And this is really quite intuitive. I mean, things that are really heavy don't speed up. It's harder to get them moving, right? Imagine, well, there's a million examples, but that's pretty much that. So what is this going to look like? Well, we could approach this equation in 3 different ways, right? I could give you a problem that looks like this. I could ask you to find the net force, right? And remember that acceleration equals the sum of the forces, also known as the net force, divided by the mass. So if I'm supposed to find the net force, it looks like I'm given acceleration and I'm given the mass, right? Acceleration equals 5 meters per second squared. Mass equals 20 kilograms. And I'm supposed to just figure out what the force is. Well, I just need to take this equation and I need to rearrange it, right? I'm going to want to multiply both sides by mass to get the sum of the forces by itself. The sum of the forces is going to equal mass times acceleration. So the sum of the forces equals ma, right? So there you go. So then you take your mass times your acceleration, right? Well, that's 20 times 5, right? And that's all you got to do there. So that's going to be 100, right? 2, 4, 6, 8, 10. That's how that goes, right? So 100, and it's a force, so it's going to be newtons, right? And if you had I probably should have had units in on the 20 and 5. The units for 20 would have been kilometers, and then that'd be meters per second squared. And a newton is a kilometer meter per second squared. So that's why that works out. All right. So I could also ask you to tell me what is the mass. For this one, I've got a couple of forces acting on it. I've got the acceleration. Remember that acceleration equals the net force divided by the mass. So what is my net force? My net force is, let's see, 10 to the right, 5 to the left. So my net force is 10 plus negative 5. It's 5. My net force is 5. My acceleration is 5. I need to find the mass, so I'm going to multiply both sides by the mass. Right? I need to get rid of the fraction, so I multiply by the denominator. Now I'm left with mass times acceleration equals the sum of the forces. But I don't want that. I want mass by itself, so I'm going to divide by acceleration again on both sides. I'm left with mass equals the net force divided by acceleration. Well, the net force is 5, acceleration is 5, so that means the mass must be 1 kilogram because it's 5 divided by 5. So that's 5 over 5. So I could give you a problem like that. What's the final thing I could possibly do? I could ask you for the acceleration. Right? So, all right, well, I remember that acceleration equals the net force divided by the mass. So what is I know that my mass equals 10 kilograms. My net force is 15 plus negative 7. What is that, 8? Yeah, that's 8 newtons. So I'm going to have 8 newtons divided by 10 kilograms, and I'm going to have like 0.8 meters per second squared in this case. So that's really all I could do. If I give you an equation that says acceleration equals the sum of the forces over mass, well, then the only possible types of questions I could give you is I could ask you to find the acceleration, I could ask you to find the sum of the forces, or I could ask you to find the mass. All right. I hope this was helpful. I'll see you in class.